the attacker will send a crafted SYN packets. Okay, a lot of them, right? So sends a lot. Send one. So let me put it back nicely. SYN packet 1, 2. SYN, let's see. Okay. So let's say Bob's buffer can hold K SYN packets. So it's all full. So this time it's all full. It's all in. It's all in. So then Bob will need to send also a lot of acknowledgement back. Okay. However, these crafted SYN packets means the source IP has been changed, okay, to an unreachable, but real IPs. So unreachable means that Bob will not receive the expected acknowledgement, right? So Bob expected K acknowledgement packets. But since these source IP are not reachable, so Bob will never get these packets back. And of course, it needs to have real IPs because Bob can check the domain name, can check to see whether some IP are not reachable. So this is a real machine's IP is real, but it's not reachable. For instance, maybe that particular IP doesn't respond to any requests, that particular machine or that particular machine is shut down or taken off from the network. But in any case, so then this Bob will in a time period, so this is a preset time period before these SYNs are removed. Before these SYNs are removed, Bob can no longer respond to new requests. Because its buffer is full. So then that means Bob's machine is now muted. Okay, so this is called SYN flooding. Attack. Okay, so that's the idea of SYN flooding attack.
What does this get
okay,
the
so
attacker?
Yeah. Say it again.
What does the attacker receive, like, get from SYN flooding someone?
Oh, so you can for instance, one possible application is to hijack a TCP connection, which we are going to talk about next, or
Okay.
you simply launch a denial of service attack.
To make sure that they can't do anything.
That's right. So just
All
bring a particular server down.
Yeah.
Move back to our slides. Okay, so I already explained the SYN flooding attack. So now let's see how we can use SYN flooding attack to launch, to hijack a TCP connection. So again, let me open up. Let me go through this. Okay, so let V be a company's server. Okay, Alice be an employee of that company, and Alice is going to remote log in to V. Okay. So that means, let's say I have a V. It's a company server, and Alice wants to remote log in going through internet by sending SYN request. Okay, and saying I want to establish this connection. Okay, so now we have an attacker. Let's say this attacker gets in the middle. So the attacker now is here. Okay, so attacker intercepts this SYN request. So rather than forward this SYN request to V, what attacker would do is to send acknowledgement. Send acknowledgement back to Alice. Now, of course, so attacker needs to figure out a correct sequence number, but that's not hard to do. Okay, and so the Alice then will send a acknowledgement back. So this time it sends back. Suppose that packet will need a send it to V, but again, the attacker intercepts it. Okay, so V never gets anything, but instead, Alice thought that she created a connection with V, but actually, what she creates, the connection Alice creates, is with the attacker. Okay, so this is the slide. So Alice sends a SYN packet to V. The attacker intercepts this packet. So now let's see how a TCP hijacking is done. In the previous video, we already talked about a brief idea of TCP hijacking. Okay, so once again, assume that Alice wants to log on remotely per company's server V. Okay. And going through the internet. Okay. And then assuming attacker okay, so this is by sending a SYN request. So TCP connection. So the attacker intercepts it. Okay, and before the attacker sends back a acknowledgement to pretend the attacker is V. So in order to make sure that V didn't get any requests from Alice, so this attacker wants to silence V first. So he will send a lot of SYN flooding SYNs. He will first launch a SYN flooding attack. So there's a SYN flooding attack to mute V for a short period of time. So so even though now V has a buffer of a certain size, so when the buffer is full, there no other data gets in, including cannot get in to complete the three-way handshake. So when it is full, then three-way handshake cannot be completed. So so this is a full. A lot of SYN requests is full. So even though V gets SYN from Alice and sends back an acknowledgement, but it couldn't get so we cannot complete a handshake, three-way handshake with Alice. Okay, so now, so the attacker mutes V first, and then sends an acknowledgement back. Okay, with, say, this is a S, and this time with a correct FX. Okay, plus plus a source IP plus, so this in this packet plus a source IP. Change to this IP. So even though
Professor?
it comes from attacker's machine, but then it looks like this packet comes.
Yes.
So I understand that information and packets have to travel from through routers to get from point A to point B. But how does an attacker insert themselves in between a route to pick up a packets and interfere with the traveling of the signal?
So one way, there will be, so this is sort of like, this is art, right? Attacking is art. So
yes.
You may say compromise a router on the path. So you first need to do some investigation and say, okay, the connection from Alice to her company's machine would usually go through this route. you can then using maybe you could use a Trojan horse, right, to lure somebody from that machine to download your software. Then you can compromise that machine, right? So that is one way. Or you can simply put yourself in as a router and lure people to use it. For a while, it looks legitimate, so people will not suspect that you are an attacker, but then when you really do want to launch an attack, then you can do it that way too. So there will be several different ways to do it. And for this particular attack, it was a real story. Okay, so that was around 1995 to 1997. There was a guy at Raleigh, North Carolina, used this attack to get into I think either Xerox server or some other big company's server from Raleigh. Okay, so this is real, but then how exactly you're going to do it, you got to use different tricks in order to place yourself to get these packets. But once you can get these packets, because of the TCP IP protocol that actually allows you to do this, you can actually hijack a TCP connection. By hijacking really means that Alice really establishes a TCP connection, but that connection is established not with me, instead it is established with the attacker.
Okay.
Would that make sense? And then the attack, once Alice thought that attacker's machine is a B, then of course attacker can ask username and passwords, and Alice think this is the server. So then she would just put in her login name and password.
Yeah. Okay.
Yeah. Yeah, that was exactly what happened some 20 years ago by this guy. Yeah. So I have more details in the textbook. I guess this guy was later indicted and sent to prison for a few years.
Comes from V. Okay. So then Alice then will complete a three-way handshake. Okay, by sending acknowledgement back. So during this time, V is still silent. It has been silenced. Okay, so then the actual connection is established between Alice and the attacker. So the reason this could be done is that let's see. So actually, this is source IP changed to attacker's IP. Okay. All right. Okay. Actually, this source IP here. So source IP here is attackers. Source IP being attackers IP. Okay, and then Alice now. So as long as this f of x is correct, okay. So as long as fs is what Alice expects, then it will go through. Okay, so this means that Alice and the attackers will establish a TCP connection instead of Alice and V. Okay, so this TCP connection then is hijacked by the attacker. The reason this can be done is TCP doesn't track IPs. Okay, so TCP header does not include IPs. It only checks the sequence number. And because it does not check IP, so this connection, this TCP connection can be hijacked. So the way to counter TCP hijacking is to check IPs. So it's a countermeasure. Check IPs. Okay, if IPs have been changed, then it knows that this connection is probably being hijacked. Okay, so now let's move back.
So is there another layer on top of TCP that can check IPs, or?
Yeah, after that, people just added a few lines of code. So that when you establish connection, always checks the IP packet, the IP address.
Okay.
Yeah, but that wasn't part of the design of the original TCP. But now it's fixed, right? So this trick, of course, all the stories we'll talk about here, that of course it happens once, but then people found solutions to them. So the reason we went over these things is just to give you some ideas that the establishment of data communications are based on protocols, and protocols often, when people design those protocols, they often overlook the security issues, and then the attackers may take advantage of those. Right? Yeah. And so then, of course, we want to come up with a mechanism so that we have this mechanism on top of the existing data communication protocols, even though some of the loopholes have not been exploited by attackers yet, right? So we want to say, okay, I want to protect whatever data communications I have, regardless what's the underlying communications.
Okay. Now let's look at ARP spoofing. So in this attack, the attacker changes the legitimate machine address of a networked computer to a different MAC address chosen by the attacker. Okay, so that's why it's called ARP spoofing. ARP stands for Address Resolution Protocol. And the defense mechanism, again, is tracking. So track MAC address and its domain name. So they should match with each other. Next, we are going to look at a buffer overflow exploitation. Okay, so buffer overflow is also referred to as buffer overrun. Is a common software flow. Okay, so in early days, there were a lot of C programmers. When they declare a string on an array, they don't need to set a bound for the strings and arrays they declared. Okay, so hence some of these bounds can be without bounds, then there is a way to exploit this problem. So it is possible to exploit buffer overflow to redirect the victim's program to execute attacker's own code. So now let's look at how the memory layout. So when you run a program, certain memory locations is reserved for running that program. So the memory from low address to high address is divided into two parts. One is called heap, the other one is stack. Okay, so the stack part, the lower, so here is a high address, but in this part is used to store functions, parameters, and the return address, right? When you call a function, that means you, in your main program, you got the, at that point, you got a detour to run that function. And when that function is done, then you need to go back to the, to where it is. So that will be the return address. And the buffer area is used to store global variables. So if some of these global variables are arrays or strings without bounds, then they are allowed to be overwritten. So if you imagine that, so this part, okay, so there is an array here. So then if my array is overwritten, so let's say this is my array, that's long, okay, so this is my array, that's long, and then because it is allowed, since you don't set bounds, then to override return address. So if you can figure out where that return address is, then you can put an address of attacker's code. In this return address. So when these functions are finished running, so you go back to the return address, and this time you are actually going to run attacker's code. So that is buffer overflow. Okay, so let me erase this. Okay, so then again, let me repeat the general steps of buffer overflow attacks. Number one, find a program that is prone to buffer overflows. For example, programs use functions that do not check bounds. As I mentioned earlier, C does not require setting bounds when you declare an array or a string. Okay, so if they don't check bounds, then that means they allow data overflow to happen. So then step number two, figure out the address of the attacker's code. That's not hard. So the hardest part will be step number three. Determine the number of bytes that's long enough to override the return address. So this requires sophisticated understanding of the memory management, the memory layout of running a particular program. Number four, overflow the buffer. Okay, so design how you're going to overflow that buffer, and so that you can put the attacker's the address of the attacker's code in the return address area. So overrun the buffer that rewrites the original return address of the function call with the address of the attacker's code. Okay. So the countermeasure is, first of all, you need programmers need a check bounce. Okay, whenever they declare an array or a string, they need a check bounce. When the bound is if the bound is exceeded, then you should stop. Okay, so that buffer overrun cannot happen. But then, since there are so many programs out there in productions, they didn't have that bounce checked. So going back to fix those code would be a lot of work. So another way is to do something on the compiler. So when you compile a program, and when you call a function, so the compiler will insert a random canary value before a return address. So this is like this. Okay, so before we have this return address here. So this is a stack. So you have a return address. I want to make sure this will not be rewritten. So what I do is I insert a canary value, because this is random value. That's called canary value. So buffer overflow has to go into this direction. Okay, in order to override the return address, you have to override the this canary. So let me put a canary value. So you need to override that canary value, and it is hard to guess what that canary value is without rewriting it. Okay, because it is random. It is random. Okay, so hence, if this canary value is changed, then of course it will know that you are not going to run. You should stop there, because otherwise you're going to run the attacker's code. So that's another defense mechanism. So speaking of using of canary value, there is a story for using canary in mining. Okay, in mining. So in early days, there was no advanced technology to detect whether there is any harmful gas in the mine, right? So this is a very deep mine. So let me start a screen whiteboard. So this is a very deep mine. All right. Okay. So there may be harmful gas. So this is a mine. This is the entrance. Okay, so there may be harmful gas, like carbon dioxide, right? So this is some harmful gas. So there is no way before a human going down, you could find out whether there is a harmful gas or not. So that's in old days. So people thought about a method to detect it. So what they do is they roll down a cage, okay, and then there is a bird in it, canary bird, right? So there is a bird in this cage, okay, so that's canary. So for a little while, and then they roll it up again. If the canary is still alive, then that means there is no harmful gas. Otherwise, then of course it means if the canary is dead, then harmful gas is detected. So that's the story of using this term canary value to detect whether a return address in the stack of is a memory layout for running a program has been modified. Okay. So now let's go back. Okay, so
Professor?
Yes.
the next.
Yeah.
Before we move on to the next thing. So do programs normally have defined amounts of buffer, or does it change depending on the hardware that they're on? For instance, like, do they have more buffer if they have a better hardware?
It really has nothing to do with the hardware because when you write a program,
Yes.
so normally let's say you declare an array or a string, right?
Yeah.
Normally you would need a set a bound. But in early days, in particular, if people who wrote C programs, they don't need to set a bounds. So which means they just declare a string or an array, and then these bounds can be overwritten. You can say you want more, then you just make a bound larger. Okay, then, so that is your program. Now, if you have enough memory to yourself, that seems okay. But then if you put your machine, particularly if you put a server on the internet that runs programs that have these unbounded array things, right? So unchecked things. And then the compiler, when you run the program, the compiler sets up or reserve a particular memory space for running that program. So that memory is typically divided into global variable for global variables, and the other part is for the local functions, for functions, which means local variables, parameters, and return address. Now, you imagine that I call a function that by setting a very large string that will override your heap area. So that means you will have to go to the stack area, right? So one is the heap, the other one is a stack. So if you put in a long string or long array, so you have to override something if that's allowed, right? So of course it has to be allowed first. But in early days, this program, they don't check bounds, so that's allowed. So that means in theory, you could rewrite the return address. So would that make sense?
Yeah.
Yeah. But then of course, how you're going to rewrite that return address to actually fit in, so to actually include the address of the attacker's code is a highly sophisticated engineering job. Okay, you gotta know all the details, but it can be done. Lots of people have done it. All right, so right now we can only talk about this is theoretically this can be done, and people have exploited this to launch software exploitation attack by rewriting return address to the address of, to put the address of the attacker's code in it. So then you want to fix this problem. So one way to fix it is to educate programs that when they write arrays or strings, they have to put a bounds there. So you cannot allow buffer overflow. The other one, of course, obviously you cannot simply go back to check every single lines of code that have been put into production for so many years, right? Because the C programs have been out there for a long time. So you cannot do this. Then what happened is, okay, how about at the compiler level, I'm going to add a little check, like a little gatekeeping kind of thing. So put a check for the row check, right? So this row check is a random number. Right before your return address, I insert a random number so that the attackers will not be able to guess what that random number is, even though the attacker figured out how to rewrite that return address. Since he doesn't know the exact random number I put in front of the return address. So that means the attacker will have to rewrite that address. Hence, the compiler will know if that address has been altered, the compiler knows that something happens. In other words, buffer overflow has happened. Then you stop running that program at that time.
Okay.
Does that make sense?
Yeah.
Yeah. But then, of course, how do you do this is a highly sophisticated engineering job. You need to really understand the underlying program in order to do that. But it can be done. And if you, years ago, you can even get some kind of toolkits or some kind of steps. Some people posted things that you can follow and try it out. But again, it's not that easy to do by ordinary programmer, but it can be done.
One is attack is data repudiation. So this means that in some situations, the owner of the data may not want to admit ownership of the data to evade legal consequences. For instance, an owner send out some rumors and that actually very harmful, and then later on he would deny that data was that data came from him. So that's data repudiation. Okay, so the defense method is to use a strong authentication to make sure that the data owner cannot deny owning that data. Okay, the next type of attack is intrusion. So this means that a real legitimate user gains access to someone else's computer system by impersonating a legitimate user or using other means, for instance, configuration loopholes, protocol flaws, and software side effects. Okay, but in any way, they get into a system by impersonating a legal user. Otherwise, a system can find out someone else which is not allowed to come in, then it's an intrusion. So usually intruders will disguise themselves as a legal user. So intrusion detection is a technology for detecting intrusion incidents, closing TCP and UDP ports that may be exploited by intruders can also help reduce intrusions. And IP scans and port scans are common hacking tools. But of course, for legitimate users, they can also use IP scans and port scans to identify in their own systems which ports are open, which should not be opened. Okay, so that means it could. They are just tools, right? So you use the tools for doing good, and some people can also use the same tools for doing bad things. The next attack is traffic analysis. So the purpose here is to determine who is talking to whom by analyzing IP packets, because IP packets have headers that have the destination IP and source IP address in it. Okay, so even if the payload of the IP packet is encrypted, the attacker may still obtain useful information from analyzing IP headers. Okay, so if suddenly the usefulness of traffic analysis is trying to figure out whether there's something big happened between two communicating parties. For instance, if one end is a army division, so this is a computer in a headquarter of army division, and the other computer is in a, let's say, Pentagon, right? So if suddenly there are a lot of packets going on between these two, then the attacker may be able to figure out something big is either has happened or is going to happen. It's going to happen. So the defense method is also, so here is, in order to hide the sender and the receiver's IP addresses, you would need to encrypt IP headers as well. But then if the IP headers are encrypted, how can you forward, okay, encrypted packets? Okay, so in this case, a network gateway is needed. Okay, it's like this. So so this is originally, this is a IP packet, okay, but then this IP header has to be in plain text. Now you so right here, right? So this is the original. Let's say in the example I just mentioned, this is a Army Division's headquarters. This is a Pentagon. Okay, so in order to send a packet from one to, so from this machine, okay, so from one of these machines. So this is a Army's headquarters, this, oops. And this is Pentagon, a particular location, right? So this IP header has to be remain in plain text, but then the attacker can figure out who is talking to whom. So to hide this, you need to encrypt it. So it's like this. So this orange part is encrypted, but you need for the TCP IP to work, for the packet forwarding to work, you need IP address to be in plain text. So to solve it, we add a gateway machines. So this gateway A is for this edge network. So there are so many machines, right? The particular Army's headquarters or some others. Okay, so all of these will share the same gateway. So for this gateway, it adds its own IP address in plain text. So that way, this packet can be sent over through the internet. So this is in the internet going through a few routers and then eventually sending to the destination gateway. So that's B. And the Pentagon, maybe it's a particular office A, particular office B, and so on, like some kind of a situation room or something, right? So all of these share the same gateway, and including some others. So this way you can, so there's a packet can still be sent over, but the actual source and the actual destination will be hidden, okay, will be hidden from the attackers. Okay, so and of course for gateway A, it knows its machines, right? So it knows these hosts. Gateway B knows these hosts as well. So encrypting the entire IP packets, okay, including the header, is called a tunnel mode. Okay, so it creates a secret tunnel using gateways. The next attack is denial of service attacks. The goal here is to block legitimate users from getting services they can normally get from servers. There are two kinds of denial of service attacks. One is called DOS. The other one is DDoS. So this stands for distributed denial of service attacks. So DOS is launched from a single computer, and a DDoS will be launched from a group of computers. Okay, of course, the attackers will still control this group of computers. And this group of computers are usually called zombies. So now let's look at a DOS attack. An example of DOS attack, the scene flooding that we talked about last time is a typical and effective technique used by DOS attack. Okay, for instance, the Smurf attack. So you mute a particular host computer so that host computer cannot establish TCP connections with any other hosts, is a DOS attack. The other one is called, the other typical one is called Smurf attack. Okay, so in this case, the attackers, okay, in this Smurf attack, the attacker sends a pin packet to a lot of hosts, but then the source IP of this pin packet has been crafted to be that particular, a certain victim's IP address. Okay, so this pin is sent from one attacker's machine, sends to a lot of hosts, but in each of these pin packets, the source IP has been crafted to be the victim. the victim's IP address. Okay, so all of these hosts that receive this pin packet are supposed to return a pawn packet. So ping pawn, right? So got a pin and then got a pawn, ping pawn. But the pawn packet will look at the source IP of the ping packet, so that all directs to this victim's server. So they all send these pawn packets back to the same machine, and hence it will crash the resources of the system, okay, of this victim's computer. Resulting a denial of service attack. So the countermeasure, of course, is to get rid of or to disable ping pong, okay, facilities, okay. A distributed denial of service attacks would be something like this. The attacker will first control or compromise a bunch of computers. For instance, they could use Trojan Horse to lure these computers to download certain software, and that software allows the attacker to control these machines. And after that, these machines are called zombies because there is a zombie program installed. The attackers can control those zombie program, and each of those zombie program can launch a Smurf attack or launch a crafted SYN packet, right, and flood the victim's computer. So they can all launch SYN flooding on the same computer and crash that system. So the reason to use denial of service, distributed DOS, is the attacker trying to avoid being traced, okay? Because if you want to trace, you can only trace to these machines, okay? All right, and the next attack is spam mail. So spam mails are uninvited email messages, which may be commercial messages or phishing messages. They may not be intended to bring the user's computer out of service, but spam mails do consume computing resources. Okay, so spamming also occurs in web search engines, instant messaging, blogs, mobile phone messaging, and other network applications. So the countermeasure is to use the spam filters to detect and block spam mails from reaching the user's mailbox. Okay, so spamming happens all the time. Okay, so while they are not intend to be taking your computer out of service, but they do consume your time by reading at them, and also consume resources of your machines by handling them. Okay, so next attack is to use malicious software. So these malicious software packages are intended to harm computers. Okay, so there are several kinds of them, such as viruses, worms, Trojan horses, logic bombs, backdoors, and spyware. So viruses and worms, they are programs, okay? In particular, a computer virus is a piece of software, a piece of code that can reproduce itself. But a virus is not a standalone program. It must attach itself to another program or another file which can be executed. Okay, so a program or file that contains a virus is called an infected host. A computer worm is also a piece of software, but this is a standalone program that can reproduce itself. And the defense method is to make sure that you do not download software from untrusted websites or other sources. Do not open any executable files given to you by someone you do not know. And make sure software patches are installed and up to date. And use virus scans to scan your systems once in a while to make sure none of your programs and files are infected. A Trojan Horse is also a program, but it appears to do something. And it actually does what it says it will do, but secretly, it also performs other things, okay? It contains a piece of warrior code to do something you don't like, right? So that's a Trojan horse. So a Trojan horse often disguises itself as some desirable and harmless application to lure people to download it. But then once you download it, that warrior code will be, when you execute that program, the warrior code will be executed as well. So the defense methods is to use the same measures of combating viruses and worms, such as do not download programs, so do not download software from untrusted sites. Okay. Virus scans can also detect, quarantine, and delete known Trojan horses. Okay. The next one is called logic bombs. Okay, logic bombs are subroutines or instructions embedded in a program. Their executions are triggered by conditional statements. Okay, for instance, a vicious employee may write a few pieces of code in a program that, if certain conditions are met, that piece of code will be executed. And for instance, that piece of code may simply delete certain files on the same directory. So that's a logic bomb. A vicious employee may do so to try to protect his position. For instance, if he didn't log on to he didn't use that program for a period of time, then the condition is met, then the logic bomb is executed. So a defense methods. Okay, so first of all, you want to reduce vicious employees. That means employers should take care of their employees so that none would be tempted to place a logic bomb in it. Okay, and then of course we'll also need. So this is not enough because you cannot always guarantee you don't fire any programmers. So then project manager should hire an outside company or form a special team of reviewers from a different group of people other than the developer to review the source code so that no logic bombs can be placed in it. And of course, relevant laws should be established so that employees who planted logic bombs will face criminal charges. Backdoors are secret entrance points to a program. So this is often used for a software developer to get into its program without entering passwords. Okay, so but then it could be done on purpose for bad reasons. Okay, even if it's for a good reason. When the software is released, that backdoor may not be removed. I just forgot the programmers forgot to remove the backdoors. Okay, so this actually happens, and
Well,
so this actually happens. I think in late 1990s, and one of the Microsoft Windows operating system new release contains.
well, so my time is up. We don't have much left, so I would like you to finish up watching these videos, and also we have some other videos so that they are not technical parts, so you can look at, for instance, attacker profiles and network security models by yourself. So these are not technical, and in here it just talks about in general what kind of network security models we are going to adopt. So basically we're going to have an encryption layer, we have an authentication layer, and then we're going to have a intrusion detection layer and anti-malicious software layer. So these are the four major layers we're going to use to build network security protocols, and we're going to use those layers in our practice. Okay, when we use or manage data communications or networked computers. So they are not technical, so you can just read them yourself. So next time we're going to start chapter 2, that's encryption algorithms. Okay, so are there any questions? Okay, then.
So,
okay, yeah, go ahead.
The quiz and the discussion codes are due on Wednesday.
That's right.
And they are
Wednesday
all about,
midnight.
they are all about chapter 1.
Chapter 1, yes.
All right.
Yeah. All right, other questions? All right, then see you on Wednesday. Bye-bye now.
Have a good one.
Yep, good night.
Bye-bye.